Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to show you how to predict the charge of an atom, understanding what's going on at the atomic level with the electrons. So let's get into this. But before I begin, please make sure you subscribe to my channel, like this video if you like it, share this video, make comments in the comment section, subscribe to my channel, hit that notification bell. Okay, let's get into this. Okay, so how do we predict the charge of an atom? Okay, so I'm going to be using the Bohr model. The Bohr model is not the most accurate model, but it is a simplified version that allows us to explain things easily. So given that in mind, that this is not the correct model, but this is enough to help explain what's going on here. So when we're looking at the Bohr model of each of these atoms, you can see that there are rings and that each of the rings has a certain amount of electrons in them. And so there is structure to this atom. And so one of the things that you want to keep in mind is that all atoms react in order to be like noble gases. What is a noble gas? Those are the atoms in the last column of your periodic table, all the way to the right. Usually there's an 8 above it, so that's column 8. We call those columns families, or we call them groups. We'll get into that later in a later video. I don't want to get too much into the periodic table. I'll talk about the periodic table and how it relates to charge in just in another video. But what the important thing is to see that each atom has a certain number of electrons in it. We learned that the number of electrons, if we're assuming a neutral atom, the number of electrons is equal to the number of protons. So if you have 8 protons in your nucleus, to balance that charge, you need 8 negative electrons. So in lithium is number 3 on the periodic table. So therefore its atomic number is 3, and therefore the number of protons is 3. And you can see that I have 3 electrons written in my atom here. So you can see that in here, according to the Bohr model, I have 2 rings around my nucleus. The nucleus is at the center. And so the first ring has 2 electrons orbiting the nucleus. And here we have 1 electron orbiting on the outer shell here, or the outer ring here. And so we're kind of figuring out, okay, so what's going on at this level? So the key to understanding what's going on when electrons become ions, in order to do that, we have to understand why they lose or gain electrons. So remember, atoms are going to become ions by either losing or gaining electrons. If they lose electrons, they're going to be positive because they don't have enough electrons to balance out the charge of the proton. So that makes them positive. If they gain electrons, that's going to make them negative because the electrons are negative. You've got more electrons than you do positive protons, and so you've got a negative charge. And that's all going to depend on what charge they have is going to depend on the number of electrons they lose or gain. But the question then comes up, what determines how many electrons they lose or gain? And that there is related to the noble gases. The noble gases is key to understanding this. So the noble gases, that group all the way to the right of your periodic table, that number 8 group. That 8 is a magic number. It's a very important number. Keep that in mind. We'll talk about that in another video, but I'll hit on it here a little bit. So you'll notice here that I have 2 noble gases. So helium is in the first row, and neon is in that second row. We call those rows periods. Again, we'll get to that in another video. So helium is At the top of the 8th group, all the way to the right of the noble gases, it's the first one on top, and then the next one is neon on the bottom. And so you'll notice that the shell here for helium has 2 electrons. And you'll notice here that the inner shell here of lithium, beryllium, boron, and nitrogen all have 2 electrons in that first shell, just like helium, right? And the same thing, I got oxygen and fluorine here, so they have 2 and 2 in that first shell. And you'll notice that I've written out the atoms in that second row, that second period. So that second row or period of the periodic table is lithium, beryllium, boron, nitrogen, oxygen, fluorine. I skipped carbon for a reason. I'll get to that in a moment. So let me just show you the periodic table of what I'm talking about here. So you'll notice I have here, this is your group 8 over here. So you'll notice it says group 8 or 18 or 8A. So there's 2 ways of numbering this. So 8A is what I'm looking at here. So you'll see helium as the first one, and you'll see neon as the second one. And if you go across the row here, right? So here you have lithium. Oops. You have lithium there. You have beryllium. And then on the other side, you have boron, carbon I skipped, and then you have nitrogen, oxygen, fluorine, and then neon. So that's there on your periodic table. So here's what the structure of the atoms look like. So you'll notice again that the inner shell has 2 electrons, and that is just like helium. So after helium on the periodic table, all the atoms have 2 electrons. So that seems to indicate that that first shell only can hold 2 electrons maximum. Okay? So that shell is considered full. Okay? Here, neon, that second shell has 2 electrons, but then you'll notice that neon has 8 electrons. So that shell would be considered full as well. So any atom after neon is going to have that full shell. And notice when I go from helium to lithium, I add a shell, right? So you can imagine if I go from neon to the next one, which I believe is calcium. Let me look. Sodium. My bad, sodium. So sodium would be next after neon. And so you add an electron. Where is it going to go? If this is full, where is that electron going to go? It would go to another shell. So you would have to add another third shell to it. So you add a third shell around here, that electron will go in that shell, and so on. So that's the first thing I want to kind of point out, this kind of pattern here. Okay? So hopefully you understand what I'm pointing out. Why is this important? Why am I pointing out, oh, this first shell is full with 2 electrons, and this second shell is full with 8 electrons. 8 electrons, however that works on my hand. I'm holding a marker, so it's hard to show. So it's full with 8 electrons. Okay, so why is that important? So the noble gases have a full outer shell. They are stable because of that. So noble gases aren't going to react, right? Noble gases aren't going to react. Why? Because they have a full shell. So all of chemistry, all of these reactions are in large part due to the fact that atoms want to have that full shell, just like noble gases. So all the elements, all the atoms want to be like noble gases, just like all basketball players want to be like Mike. Sorry, I'm from Chicago, so that's the way it is. So Michael Jordan is the GOAT. Okay, so moving on. So when we're trying to understand why these atoms lose or gain electrons, we have to think, well, they want to be like a noble gas. So they're either going to lose electrons or they're going to gain electrons to be like a noble gas. And so we have to look at which noble gas is closest to your element. So I have these written down here. So if we look at lithium, which noble gas on the periodic table is closer to lithium? Take a look right now. I'm serious. Take a look right now. Which one is closer? Yes. So lithium. Lithium is closest to helium, right? Helium is closer to lithium. And so you can ask yourself, okay, so lithium has one electron on its outermost shell. And by the way, we call this outermost shell the valence shell. And electrons on that shell are called valence electrons. So if I ever use the word valence electrons, you know what I'm talking about. Valence electrons are the electrons on the outermost shell, which is called the valence shell. So we have one electron on the valence shell, one valence electron. So it could either lose that one electron to be like helium, or it could gain 7 electrons to be like neon. So the question is, which is easier, to lose 1 electron or to gain 7? Obviously, it's easier to lose 1. So that's exactly what it's going to do. So that lithium atom loses 1 electron. Now, of course, that 1 electron doesn't just go out into space. Actually, it needs something else to take that electron away, right? So we're not going to get into that. That gets into ionic bonding and all that stuff, or covalent bonding, which that'll come later. But right now, the important thing to notice is that lithium is going to lose an electron to another atom, and then it's going to have 2 electrons here and no electrons here in this outer orbit. So really the outer orbit is empty, so that outer orbit is no longer the outermost shell or outermost orbit. It's now, this one is the outermost orbit. Now it has a full outer shell. So now it's just like helium, which is a noble gas, but it lost an electron. So now it has to have a charge. So it lost a negative electron. That means there's 1 proton not being balanced. So that's a positive charge. So that means lithium has a +1 charge. We don't write the ones, we just write a plus. So it's got a +1 charge there. Does that make sense? Okay, hopefully it does. Let's go to the next one. So beryllium has 2 electrons on its outermost shell, so that's 2 valence electrons. And so again, the question is, what is this element going to do? What does this atom want to do? It wants to be like a noble gas. So which noble gas is it closest to, right? So it could either lose these 2 electrons to be like helium, or it could gain 6 electrons to be like neon. If you look on the periodic table, you'll notice that helium is closer because, and it also makes sense that losing 2 electrons is easier than gaining 6. So it's going to lose those 2 electrons to some other atom, right? So in the process, in a chemical reaction with beryllium, beryllium is going to lose those 2 electrons. So it loses 2 electrons to some other atom or atoms. And so in the process, it loses those 2 electrons. The outermost electrons are the ones that are lost, not those. It's the outermost electrons. Those are the easiest to remove. The reason that those are easy to remove is because the energy of the electron gets larger, or the farther it gets away from the nucleus, those are easier to remove. And so we'll talk about more. I don't want to get into the weeds of that. But just note that the outermost electrons are the ones that get removed, not the innermost. So the outer ones. Okay, so then that means that this atom now of beryllium no longer has 2 electrons in its outer shell, right? So it has 2 electrons. Let me go back to lithium. I'll write here, make this more obvious. This has 3 protons plus positive protons. And so you have 2 electrons, negative electrons. You have 3 protons. And so there's a positive 1 charge. So that makes that more obvious. Here we have 2 electrons, but beryllium has an atomic number of 4. That means it has 4 protons. So we'll have 4p plus. But it only has 2 electrons because it lost 2 electrons to be stable like helium, a noble gas. And so now the charge on that has to be a 2 plus charge. Oops, wrong symbol. A 2 plus charge. Okay? So far, so good. Oh, lights. Sorry about that. So what about boron? Boron has 3 electrons. And so keeping the pattern, so we look at the noble gases. It wants to be like a noble gas. So either it's going to lose 3 electrons to be like helium, or it's going to gain 5 electrons to be like neon. Which is easier to do? Obviously, helium. And helium's closer to it on the periodic table. So in order to be like helium, it's going to lose those 3 electrons. So again, those 3 electrons are going to go to some other atom in the reaction. And then again, we end up with only 2 electrons on this inner shell. And so this orbit goes away. So the outermost orbit is the 2 electrons here. So it now has a full shell. Again, this has a full shell, outer shell. And so these are now stable like helium. And again, boron has 5 protons in its nucleus. It now has only 2 electrons. So that's only going to balance out 2 protons. So there's 3 protons that are not balanced. So that means it has a positive 3 charge. So we write that as B3 plus. And we can keep going like this. Now, I'm going to jump over carbon and we're going to go to nitrogen. So you'll see nitrogen here. Nitrogen has 2 inner electrons, but the outermost shell, the valence shell, has 5 electrons. So it has 5 valence electrons. So what is this going to do? So again, it could either be like helium with 2 electrons, or it could be like neon with 8 electrons. So which is easier? Is boron going to lose those 5 electrons, or is it going to gain 3? Yes, you're correct. The answer is it's going to gain 3 electrons. So instead, it's going to gain 3 electrons. Now again, those 3 electrons just don't come out of thin air. They're going to come from another atom that it's reacting with. But the point is that it's going to gain through those 3 electrons so it can be stable like a noble gas. It wants that outer shell full. And for the second shell here, that number is 8, just like neon. So the atom has 2 electrons in the outer shell, and it's going to have 8 electrons the inner shell has 2 electrons, and the outer shell has 8 electrons. So that's 4, 5, 6, 7, 8. And so now this is complete. It's now stable, but it gained 3 electrons. So the charge on nitrogen is going to be a 3 minus charge. Because how many protons does this have? Nitrogen has 7 protons. And here you have a total of 10 electrons. So you have 3 more electrons than you do protons. That's a negative charge, so that's a 3 minus charge. Okay, let's go on to oxygen and fluorine. Same thing. Oxygen has 6 valence electrons in its outermost shell. And so therefore the question is it going to lose those 6 electrons to be like helium, or is it going to gain those 2 electrons to be like neon? And again, it's easier to gain those 2 electrons than to lose 6. So it'll gain those 2 electrons from somewhere, right? So it's going to gain them from some atom somewhere. And so you get those 2 electrons coming in. And you now have an outer shell, 1, 2, 3, 4, 5, 6, 7, 8, and there's 2 on the inner shell here. And so gaining those 2 electrons, we know that because this is on the periodic table, we know that it has 8 protons because its atomic number is 8. And it has 10 electrons. So 2 electrons are not balanced out. So we have 2 negative charges that are not balanced by the positive protons. And so that means that oxygen has a 2 negative charge on it. And finally, for fluorine, fluorine has 7 valence electrons. And that means that it can either gain 1 electron to be like neon, or it can lose those 7. Obviously, it's going to be easier just gain that 1 electron from somewhere. And so that means that it's going to have an extra negative on there. 1, 2, 2 electrons in the inner shell. 1, 2, 3, 4, 5, 6, 7, 8 electrons in its outer shell. So again, a total of 10 electrons. The number of protons here is 9, so it has 9 protons. And so that means it has 1 extra electron, so the charge on fluorine is going to be a -1. Again, we don't write the ones. And so here, again, the upshot of all of this is that atoms are going to lose or gain electrons in order to be like the noble gas. Whichever noble gas is closest, that's the noble gas is going to be like. And you can understand that from the fact that which is easier. If you have less than 4 electrons, it's going to be easier to lose those electrons than gain, 6, 7, or 8 electrons, or 5, 4 electrons, and so on. So this is how you can understand whether or not an atom is going to lose or gain electrons and get that charge, right? So if it's going to lose electrons, if it's closer to one element and it can lose less electrons than gain those electrons, it's going to lose those electrons. And so losing electrons gives it a positive charge. And if you have 5 or more electrons in your outer shell, then it's going to be easier just to gain more electrons than to lose those electrons to be like the next noble gas. Then it's going to do that, and it's going to have a negative charge. Okay, so why do I skip carbon though? Well, what about carbon? Well, carbon is number 4, smack dab in the middle, right? So if you have number 8, right? So let me use my periodic table again. Let me show you the periodic table. So you'll notice over here we have group 1. So up here we have group number 1. So group number 1 here, we have lithium, right? That's group number 1. And then here, beryllium, that's group number 2. And then over here, you have group number 3, 4, 5, 6, 7, and then 8. Everyone wants to be like the noble gas. So guess which group is in the middle. So we have nitrogen, which is 5, oxygen is in group 6, fluorine is group 7. So there's 3 on this side. And then you have lithium, beryllium, and then over here, boron, 3 on that side. And then you'll see carbon is right in the middle, that group 4. So since they're in the middle, they can either lose 4 electrons to be like the previous noble gas, helium, or they can gain 4 electrons to be like the next noble gas, neon. So because they're in the middle, it's a little more difficult to predict what charge those elements will have. So I skipped carbon because it's kind of an oddball, but the rest of them, if you understand what's going on here and you understand like how many valence electrons they have, they're going to lose or gain electrons to be like a noble gas to fill that outer shell. And so I hope that explains everything. I hope that's clear to you. If you have any questions, please put them in the comment section. If you like this video, please hit that like button, smash that like button, and hit that notification bell. Subscribe to my channel so that you can be notified by any other videos I put out. Thanks for joining me, and have a great day.